Bismillah Rahman Rahim. Welcome to Technogenius. Our today's topic is power transmission. In this lecture, we will discuss about the basic functionality of the transformer. I will tell you that how transformer is used in the power transmission and in the distribution system. Then we will discuss the basic definition of the transformer, its working principle, its construction, and then classification of the transformer based on its constructional type, its functional type, now and nature of cooling or the cooling material used in the transformer, number of phases in the transformer, and the type of the transformer based on frequency. And then we will discuss parts of the transformer. Finally, we will discuss the transformer connection in power transmission, and then the problems which would be a practice problem for as an assignment. So initially, what is transformer? By definition, we can say that a transformer is a device that change AC electric power at one voltage level to an AC electric power at another voltage level through the action of magnetic field. But in practically, if we say that we have two-sided, one is transformer is a two-sided device. One is the primary side and the second one is the secondary side. If we say that the number of turns in the primary side is equal to the number of turns in the secondary side, then we can use this transformer as an isolation transformer. That in this transformer we have two different circuit. One is from the primary side circuit and the second one is from the secondary side circuit, but the output voltage and the input voltage is same, so it is an isolation transformer. Now the second case, if the number of turns in the primary side, if the number of turns in the primary side is less than the number of turns in the secondary side, then we can say that this transformer, the output voltage would be low and the input voltage would be high, and this type of transformer is known as step down transformer. And in the third case, if the if the number of turns in the primary side is smaller than the number of turns in the secondary side, then the input voltage would be lower than the output voltage and output voltage will be high. So in this case, we can say that the transformer which we are using is a step up transformer. One thing you should know is that the input power and the output power of the transformer is same. So it is not an amplification device. It is working just on based on the mutual induction phenomena, that the magnetic flux in the primary side is induced in the secondary side, and the output voltage is dependent on the number of turns of the secondary side. So it is a physical application of the Faraday's law. So if you understand the basic concept of the Faraday's law, by definition we can say that in the Faraday's law we are saying that whenever the variable magnetic field cut a steel conductor, it will induce EMF in that conductor. So in this case of the transformer, the primary side, when the current flow in the primary side, it will produce a variable magnetic field. When this variable magnetic field cut this steel conductor, the voltage is induced or the EMF is induced in the secondary side, and this voltage will give some power to the system. So this is a physical implementation of the Faraday's law. If we see the physical diagram of the transformer, then we can understand that there in the center we have some core, and this core is a combination of multiple sheets, laminated sheets, uh, and from in one side of the core there will be number of turns, and this side is known as primary side, and the secondary and the second side we have the number of turns, and this is the secondary side. If we divide this transformer in two sections, then the primary side circuit is totally different than secondary side, and this is a completely isolated device. The primary side is completely isolated with the secondary side, and the relation between primary and the secondary side is based on the mutual induction. So there are, if we say that from the construction point of view, we can say that we have two major parts of the transformer. One is the magnetic core and the second one is the winding. So the magnetic core, the purpose of the magnetic core is to transfer the magnetic flux from the primary side to the secondary side. Normally the structure of the magnetic core is in square or the rectangular shape, but it is a combination of different sheets connected together, laminated sheets attached together, and the material of the core is normally ferromagnetic material, and the coating is normally a silicon steel lamination coating. So our target is to transfer maximum power from the primary side to the secondary side. And the second part of the transformer is the winding of the transformer. So the winding if we see the transformer structure of the transformer, there are two windings in the transformer. One is in the at the primary side of the transformer, and the second one is on the secondary side of the transformer. So the winding are totally dependent on the number of turns. If the number of turns vary, the output voltage of the transformer varies. So so we normally use number of turns in the form of coil, and different types of materials will produce different type of magnetic induction. So normally we use copper type material in order to minimize the losses of the system. So there are in base of the construction, we can say that there are two types of transformers. One is core type transformer, and the second one is shell type transformer. In the core type transformer, we use core, and above the core we will have the windings. So the winding usually surround the core. In this case, we can say that it is a core type transformer. In the shell type transformer, the windings are in the center, and the outside material is basically the core. So the structure diagram, if you see this one, we have the core in the middle, and the winding is over on the core. Then it is called core type transformer. And in the second type, we have shell type, where what we have is that the core is in the center, the winding is in the center, and the core surround the winding. So shell is created above the winding, so it is called the shell type transformer. So if we see the losses of the transformer, the common losses in the transformer is eddy current losses and the hysteresis losses. These two losses are due to the core, because the material used in the core is ferromagnetic material. So there is a chance that it can store magnetic field. If it can store magnetic field, it will produce some phase difference and the problem in the system. This problem will be this kind of losses is known as hysteresis losses in the transformer. But if there is some charge stored in the ferromagnetic material, then some current will be flow in the material. This current flow is known as eddy current losses. So in order to reduce eddy current losses, we will use normally use sheets of core, and we combine this sheet to complete a complete block, and every sheet is laminated, so it would reduce the current carrying capacity of the conductor. Secondly, we have the copper losses in the transformer, and these copper losses are due to the winding. If the quality of the winding or the material of the winding is not pure copper, then it will produce some losses. Otherwise, if the material is copper but still due to the resistance of the conductor, there is some losses, and these losses is known as copper losses. The third type of losses is stray losses. Physically, the stray losses is due to the charging and discharging of the material used in the construction of the transformer. Like in the transformer, we have the core, and if the core is charged and discharged, like in the hysteresis losses, I already told you that the hysteresis losses are due to the charging and discharging of the core. Secondly, these stray losses can be occur in the dielectric material. Normally in transformer, for the cooling purpose, we use oil, and this oil may store this magnetic flux. If it stores the magnetic flux, it is called, in this losses are also known as stray losses. The third losses is dielectric losses. If the quality due to the magnetic flux, the dielectric capability of the oil is gradually reducing, and this dielectric strength, if it is reduced, then it will create a short circuit in the transformer. So these losses are dielectric losses. And the fourth losses is normally the mechanical losses. If you understand the basic concept of the transformer, there is no mechanical device attached in the transformer. So how it is possible to have a mechanical losses in the transformer? So these mechanical losses are practically due to the problem when we construct the transformer, and due to the transportation. जब ट्रांसपोर्टेशन होती है ना, तो उसके अंदर क्या होता है कि जो झटके वगैरह लगते हैं, जो वाइब्रेशन होती है ट्रांसफार्मर के अंदर, उस वाइब्रेशन की वजह से ट्रांसफार्मर की एफिशिएंसी डाउन हो जाती है, और वो जो एफिशिएंसी डाउन होती है वो ओवरऑल एफिशिएंसी हमारे सिस्टम को डिस्टर्ब करती है। तो हम हमेशा ये करते हैं कि जो ट्रांसफार्मर जब डिज़ाइन करते हैं तो उसे ऐसे मटेरियल के अंदर पैक करते हैं ताकि वो शॉक से अब्जॉर्ब कर ले और ट्रांसफार्मर के फिजिकल स्ट्रक्चर पे कोई झटका वगैरह ना हो, ताकि कोई मैकेनिकल लॉसेज वगैरह। तो ये डिफरेंट टाइप्स ऑफ ट्रांसफार्मर लॉसेज हमारे सिस्टम के अंदर होते हैं। नाउ इफ़ वी see the construction type of the transformer, so normally the transformer used in the industry, specifically in the transmission or distribution side, then the transformer is normally a shell type transformer. So in this shell type transformer, in the center crossing of the core we have the winding, and normally the winding is like this one. We usually have the primary winding, and above that primary winding we put the secondary winding, and in between primary and secondary winding we use some insulation material which resists the connectivity of the primary and the secondary winding. So the primary is in the center, and above the primary we would have the secondary winding. Usually in practice, the side where the voltage level is high is under the side of the winding, and the side where the voltage level is high is above, on the above side of the winding. इन शॉर्ट आई कैन, मैं सिंपल लफ्ज़ों में समझाऊँ तो ये है कि भाई जो अगर हम कोर को देखें ना, तो जो साइड जिसका वोल्टेज लेवल हाई है उसका करंट लो होता है। जब उसका करंट लो होता है तो क्या होता है कि उसका कंडक्टर साइज जो होता है नॉर्मली छोटा यूज़ होता है, और जो वोल्टेज जिसका वोल्टेज कम है और तो उसका ऑटोमेटिकली करंट ज़्यादा होगा, और जिसका करंट ज़्यादा होगा उसका कंडक्टर का साइज़ ज़्यादा होगा। तो हम हमेशा क्या करते हैं, जिसके कंडक्टर का साइज़ छोटा है, यानी कि ऐसा सिस्टम जिसकी जो है क्या नाम है, जिसकी वाइंडिंग का साइज़ छोटा है, उसको हम ऊपर वाली साइड पे चढ़ाते हैं ताकि हमारे पास कोर कम, हमारे पास वाइंडिंग का जो है मटेरियल कम से कम यूज़ हो, और जिसका कंडक्टर साइज बड़ा है उसको हम नीचे वाली साइड पे चढ़ाते हैं ताकि कम से कम मटेरियल यूज़ हो। तो अगर फॉर एग्जांपल स्टेप अप ट्रांसफार्मर है, तो स्टेप अप ट्रांसफार्मर का मतलब ये होगा कि जो प्राइमरी साइड है उधर क्या होगा, उधर करंट ज़्यादा होगा और सेकेंडरी साइड पे करंट कम होगा। तो प्राइमरी साइड जो होगी वो नीचे वाली साइड पे आएगी और सेकेंडरी साइड ऊपर वाली साइड पे आएगी। जबकि अगर मेरे पास स्टेप डाउन ट्रांसफार्मर है तो हम क्या करेंगे, जो प्राइमरी साइड है वो ऊपर आ जाएगी और सेकेंडरी साइड नीचे आ जाएगी, यानी कि इस तरह हमारे पास वर्किंग आ जाएगी। इसकी कंस्ट्रक्शन इस तरह होती है। सो अब जो थर्ड चीज़ इंपॉर्टेंट होती है वो कूलिंग होती है। हम अगर ट्रांसफार्मर की बात करें तो फॉर द ट्रांसफार्मर व्हेन द करंट पास इन द ट्रांसफार्मर इट विल हीट अप due to the current in the transformer, the coil will be heat up, and this coil, in order to reduce the burning effect, we usually use oil to absorb this heating, and this oil is used to transfer heat. We have cooling ducts, and these cooling ducts will remove the heat, and overall temperature will be maintained. So the oil normally is used as a heat sink in the transformer. So different types of oils are used depending on the rating of the transformer. Like if the rating of the transformer is less than 150 kVA, then we normally use dry type transformer. That means there is no oil in the transformer, just air or air based or cooling is used. Otherwise, if the transformer voltage level is high, like it is more than 150 kV, normally 1000 kV, 500 kV or 1000 MV, then we use special type of oil to use as a heat sink, and it will absorb the heat and transfer it into the air. So the cooling type used in in these transformers are usually of three types. Number one is we can use oil cooled system, we can use air cooled system, or we can use water cooled system. And this cooling mechanism is totally similar to the cooling mechanism of the car. Like in the car we use radiator to cool the engine. So in the transformer we use oil to absorb the heat, and then we use special types of cooling ducts which will absorb the heat into the air. So the in the if we see the functionality of the transformer, we can say that we have three types of transformer. One is unit transformer. Unit transformer are usually step up transformer connected at the output of the generator side. So in the generator side, the input would be 11 kV and it will step up to 132 kV or above. So in between, the second step is substation transformer, and substation transformer is usually a step down transformer, which are usually a 33 kV or 11 kV system. And the third type is a distribution transformer, which is also a step down transformer, which is near the residential areas, which normally take 11 kV as an input or 33 kV as an input and give 220 kV or 220 volt or 400 volt. So in short, we can say that we have one transformer in the generation side which can be used as a transmission transformer, which usually step up the voltage, and then we have two levels. One is substation level, where we step down the voltage level of the transformer and to 11 kV or 33 kV, and then we have the distribution transformer which convert 11 kV voltage into 220 or 440 near our residential field. So if you see that this is the power system, and then we have a transmission transformer over here, and this transmission transformer step up the whole system. Now we usually transmit. This is the transmission transformer and this is the transmission transformer. From the generation side we step up the voltage, and then we usually step up or step down the voltage. Now if you see, after the transmission side we have the distribution substation, where we receive the voltage and then we step down the voltage near the to transfer it to the residential area. At this side, and in this transformer the output voltage usually is 11 kV or 33 kV, and this voltage is transferred near our residential area, and in the residential area the voltage is then stepped down to 220 or 240 440 volt to the residential area. So normally in the power system we use two types of transformer based on the phase. One is a single phase transformer where we have just one primary and one secondary, and we can have three-phase transformer where we have three primaries for each for three phases, and then we have three secondary for three phases. Now we can classify transformer based on frequency. So there are low frequency transformer which are used in power system like power transmission, power distribution systems. We have high frequency transformer which are used in communication, like it would be 2 megahertz or 200 kilohertz. So it is used for communication purposes. Similarly, we have in intermediate transformers which are also used for communication purposes, which are usually in high frequency transformer. And some transformers are used in power electronics to control the switching of the system. So they are also a high frequency transformer. So based on frequency we can say low frequency transformer which is used in power. We can say very high frequency transformer which are used in power electronics and communication. We can use intermediate frequency transformer which are used in the communication purpose. So if we compare the transformer, then we have two types of transformer. One is used in for the transmission side, and the second one is used in the distribution side. In the transmission side, the usually the input the voltage levels are 500 kV, 132 kV, 66 kV, or 33 kV. While in the distribution side, the transformer voltage input voltage is 11 kV or 33 kV, while the output voltage is 380 or 220 voltage. The transmission side transformer are very big, while the distribution side transformer are very small, because the transmission side transformer are usually transmitting power in megawatts, while the distribution side transformer are usually transmitting power in kilowatts. So this is very low. Overall operation normally in the transmission side transformer are usually working in the full load condition, while in the distribution side the transformers are usually working 60 to 70% load. Efficiency of the transmission side transformer is 99% efficient, while in the distribution side the efficiency is 50 to 70% efficient. So in the transmission side, if the voltage fluctuate and the input or the output voltage varies, its voltage level is disturbed, then we have auto transformer which can automatically adjust the voltage level, and this voltage level adjustment is known as on load tap changer. While in the distribution side, we have to change the voltage level, manually change the voltage level, and this is known as off load tap changer. So these are the basic difference between transmission side transformer and the distribution side transformer. So in practical application, the transformer usually have some losses, but in ideal case there would be no losses. The winding resistance will be zero. There will be no flux leakage, and the current requirement for the magnetic flux transfer is very small. So ideally this is not possible, but practically we will try to minimize the losses. We will try to minimize the resistance losses or resistance of the winding, and will try to minimize flux leakages. So the design of the transformer is according is we are normally trying to make it near an ideal transformer. So the physical mathematical equation of the transformer is the input power is equal to output power. That means V primary I primary is equal to V secondary I secondary, and the ratio, if we calculate the ratio of the transformer, then it is I2 over I1 is equal to V1 over V2, and this ratio is 1 over K, and K defines number of turns, ratio of the number of turns. So the output voltage and input voltage is dependent on the number of turns. See, if the in short we can say that if the primary side voltage number of turns is low and the secondary side number of turns is high, then it is the step up transformer, and in this case K value is greater than 1. But if the secondary side number of turns is low than the primary side, then in this case the K value is less than 1, and it is a step down transformer. So in power system we have two different connections. We can have Y connection or delta connection. So in the transformer we are saying that we have two different circuit. One is the primary side circuit, and the second one is the secondary side circuit. So for the primary and the secondary side circuit, we can have both the connection. We can have both Y connection, we can have both delta connection, or we can have Y delta connection, or we can have delta Y connection. So there are four different types of transformer based on the connection methodology. So in some system we use Y connection, and for the Y connection we have four wires, three for the each phase, and the fourth one is for the neutral, and normally we use it for the distribution side. So we have Y connection. If you see the N is basically the turn ratio. Then we can have delta connection. For the delta connection we have the plus advantage that we use three wire system. So for the in the primary side we have three wires, and in the secondary side we have three wires, and it is connected in the delta. इन द स्टार कनेक्शन इफ़ यू सी दैट ऑल, अगर हम वाइंडिंग को देखें ना तो वाइंडिंग के अंदर दो चीज़ें आती हैं। एक वाइंडिंग आती है जिधर से वाइंडिंग स्टार्ट हो रही है और एक जिधर एंड हो रही है। जिधर से स्टार्ट हो रही है उसे हम डॉट कहते हैं, जिधर एंड हो रही है उसे क्रॉस कहते हैं। डॉट क्रॉस हम बेसिकली बनाते हैं। जब हमने डेल्टा कनेक्शन करने हैं ना तो हम क्या करते हैं, डॉट यानी कि डेल्टा बन रहा है ना, एक का डॉट दूसरे के क्रॉस से, दूसरे का डॉट पहले क्रॉस से, यानी कि डॉट को क्रॉस से मिलाते हैं तो डेल्टा बन जाता है। जबकि हम जब वाई बना रहे होते हैं ना तो वाई के अंदर हम क्या करते हैं कि तीनों डॉट्स को मिला के एक पॉइंट निकालते हैं, वो न्यूट्रल बन जाता है और तीनों क्रॉस को अलग अलग बाहर निकाल देते हैं, तो ये कनेक्शन बन जाता है वाई कनेक्शन। सो हमारे पास वाई वाई ट्रांसफार्मर अवेलेबल होता है, डेल्टा डेल्टा ट्रांसफार्मर अवेलेबल होता है। लेकिन जब हम ट्रांसमिशन लाइन में बात करते हैं तो फॉर द ट्रांसमिशन वी यूज़ डेल्टा डेल्टा ट्रांसफार्मर। So in between transmission we have primary transmission and secondary transmission. In the primary transmission we are taking power from the generator side and we are transmitting the power to the transmission side. So in the generation side we usually have input y and the output is delta. But in between some transmission line we use secondary transmission. So the input is delta and the output is also delta. So we can use these transformer in the transmission lines. Similarly we can have delta y delta transformer. So the primary side is y and the secondary side is delta. So we can use this type of transformer too. And the last one is delta y. The primary side is delta and the secondary side is y. तो अगर आप ये देखें ना तो ये जो ट्रांसफार्मर है ये हमारे जो रेजिडेंशियल एरिया में जो डिस्ट्रीब्यूशन ट्रांसफार्मर रखते हैं, जो ग्रिड स्टेशन से 11 kV लेके आ रहे हैं और आपके घरों में 220 दे रहे हैं, तो जो ग्रिड स्टेशन से 11 kV लेके आ रहे हैं वो 3 वायर है, जबकि आपके घरों में जो दे रहे हैं वो 4 वायर सिस्टम दे रहे हैं। तो इनपुट वाली साइड पे डेल्टा लग रहा है और आउटपुट वाली साइड पे स्टार लग रहा है, तो ये हमारे पास कनेक्शन आते हैं। सो इफ़ वी सी द पार्ट्स ऑफ द ट्रांसफार्मर, then in the physical outside of the transformer we have the conservator tank, and we have the main tank. In the main tank we have oil, and in this main tank we have some special cooling tubes. When the oil is overheated it expand and this oil is transmitted to the cooling tubes, and in these cooling tubes when the air flow the air will absorb the heat. So अगर हम कूलिंग के लिहाज से देखें तो हमारे पास क्या है कि हमारे पास कंजर्वेटर टैंक है, हमारे पास जो है मेन टैंक कवर है, और फिर इसके अंदर कूलिंग ट्यूब है कि जैसे ही ऑयल हीटअप होता है, जब करंट पास करता है तो ऑयल हीटअप होने की वजह से ऑयल एक्सपैंड करता है, वो एक्सपैंड करके कूलिंग ट्यूब में चला जाता है, और कूलिंग ट्यूब के अंदर जो है ना एयर फ्लो करती है। तो जब एयर फ्लो करती है तो वो क्या करती है, वो इस हीट को एब्जॉर्ब कर लेती है, और अगर हमारे पास ओवर हीट हो जाता है तो ये कंजर्वेटर टैंक में चला जाता है। अब फिर इसके साथ लगा होता है ब्रीदर। ब्रीदर क्या होता है, ये क्या करता है कि इसको एयर चाहिए होती है। जब ऑयल ने एक्सपैंड करना है और रिलैक्स करना है तो कभी एयर वो ले रहा है, कभी एयर निकाल रहा है, तो वो एयर प्रेशर ना जनरेट होने को रिमूव करने के लिए ये ब्रीदर लगा हुआ है। ये बेसिकली ओपन होता है, इसके दरमियान में फ़िल्टर लगा होता है, जिसका काम क्या होता है कि जब वो एयर ले रहा है तो उसमें जो डस्ट पार्टिकल हैं और जो वाटर कंटेंट है वो एब्जॉर्ब कर ले और प्योर एयर अंदर चली जाए। सही है। इसी तरह फिर हमारे पास लो वोल्टेज ब्रशेज़ अवेलेबल होते हैं, और इसी तरह हमारे पास ये ड्रेन ऑफ है कि अगर हमने ऑयल को निकालना है तो ये ड्रेन वगैरह हमारे पास लगी होती है। अगर हम दूसरे एंड पे देखें तो दिस इज़ सेकंड डायग्राम। इफ़ यू सी दैट दिस वन it is the rod for gap arrestor. If a second one is the oil level indicator, it will show the level of the oil. We have the breather. This breather is directly connected with the conservator tank, and it is known as dehydrating breather, and dehydrating mean it will absorb the humidity or the moisture of the system. Then we have the oil filter plug to filter out the oil if there is an impurity, and this whole tank is known as conservator tank. We have thermometer attached in the transformer, and thermometer will measure the temperature of the internal temperature of the transformer. Then we have the Buchholz relay. बुकल्स रिले जो है ये एक स्पेशल टाइप ऑफ रिले है, दो पर्पज़ के लिए यूज़ होती है। एक पर्पज़ ये होता है कि अगर टेम्परेचर बहुत ज़्यादा बढ़ गया तो ये सिस्टम को डिस्कनेक्ट कर दे। दूसरी चीज़ ये होती है कि अगर टेम्परेचर बहुत ज़्यादा बढ़ गया तो होता क्या, होता ये है कि जो डाइलेक्ट्रिक प्रॉपर्टी ऑफ द ऑयल होती है वो रिड्यूस हो जाती है। अगर एक सर्टन लेवल से ज़्यादा डाइलेक्ट्रिक प्रॉपर्टी इसकी रिड्यूस हो जाए तो ये बुकल रे ट्रिगर कर देती है ताकि कंडक्शन आपस में प्राइमरी सेकेंडरी कॉइल जो है वो कनेक्ट ना हो जाए। तो वो क्या करती है, ये बुकल्स रिले ऑन हो जाए। ये सिंपल रिले है, सिर्फ इसका फीचर ये है कि ये डाइलेक्ट्रिक को देख रही है टेम्परेचर की बेस पे और कंडक्टिविटी की बेस पे, जिसकी बेस पे ये ऑन ऑफ हो रही है। हर ट्रांसफार्मर के ऊपर रेटिंग प्लेट लगी होती है। ये इसकी रेटिंग प्लेट के ऊपर इसका प्राइमरी वोल्टेज, सेकेंडरी वोल्टेज, प्राइमरी पावर, सेकेंडरी पावर सब कुछ लिखा होता है। इसी तरह ये हमारे पास कंप्लीट हमारे पास इसका टर्मिनल बॉक्स होता है जो कनेक्टिविटी में हमारे पास शो हो रहा होता है। फिर उसके बाद टैंक आ गया और सेंट्रली व्हील आ गया, और समटाइम व्हील नहीं भी होते क्योंकि जब ट्रांसफार्मर को मूव करना है तो वो व्हील का एडवांटेज होता है। Now the internal structure of the transformer, if you see that this is the core, and in this core we have primary winding and the secondary winding. If you see this pink color it show the low voltage winding, and this black and white color show the high voltage winding. So and from the above side, if you see that we have low voltage side, at the low voltage side we have 4 terminals, at the high voltage side we have 3 terminals, and then we have water tank and the cooling tubes. So this is the whole transformer. So now we have the assignment. If in this assignment we have 2 questions. One is draw a 3-phase 500 kilometer 1200 kVA power system which include generation, power transmission and distribution system with all write all the power rating, voltage level, tower height, transformer primary and the secondary side voltage level आपने मेंशन करनी है। अब ये बेसिकली तो ये असाइनमेंट है कि आपने सिर्फ इसको ड्रॉ करना है, लेकिन आपने इसके अंदर एक एक चीज़, एक एक रेटिंग को मेंशन करना है। अब हर बंदे का अपना डिज़ाइन होगा। किसी को लगता है कि भाई जो है प्राइमरी साइड का वोल्टेज ये होना चाहिए, सेकेंडरी का कोई और होना चाहिए, किसी को कुछ और लगता है, तो वो अपनी मर्ज़ी से करे। अब जब वो सेकेंडरी साइड का वोल्टेज डिफाइन कर देगा तो फिर मैथमेटिकल फार्मूलाज हैं जिसकी बेस पे आप डिफाइन कर सकते हो कि टावर की हाइट कितनी होगी, और जो है जो उसके अलावा जो है जनरेशन और डिस्ट्रीब्यूशन साइड पे अगर आपने नंबर ऑफ़ ट्रांसफार्मर्स बढ़ाने हैं तो उधर हर पॉइंट पे फिर टावर की हाइट कितनी होगी, यह आपने डिज़ाइन करना है, या आपने एक लेआउट ड्रॉ करना है। फिर दूसरी चीज़ है ब्रीफली डिस्क्राइब द फंक्शनैलिटी ऑफ ऑल पार्ट्स ऑफ द ट्रांसफार्मर, ट्रांसमिशन टाइप ट्रांसफार्मर। तो ये जो पार्ट्स मैंने बताए हैं ये डिफरेंट पार्ट्स हैं इन 3 फिगर्स में। इन पार्ट्स को ब्रीफली डिस्क्राइब करना है, 2 to 3 लाइन्स या 4 लाइन्स में इनको डिफाइन करना है। थैंक यू, जज़ाकल्लाह। अपना ख्याल रखिएगा, अल्लाह आपके लिए आसानियाँ अता फरमाए और आसानियाँ खल्क़ खुदा में तकसीम करने की कोशिश तौफ़ीक़ अता फरमाए। अगर आपको ये लेक्चर पसंद आया तो ये चैनल को ज़रूर सब्सक्राइब करें। जज़ाकल्लाह।